Welcome to my channel. In this video, I'll be talking about list comprehensions. List comprehensions are Python's solution to creating and transforming lists efficiently. Okay. So what does list comprehensions look like? They have a very basic structure. You'll have a square bracket, open and close. Within it, you will have output expression, a for loop, an input sequence, and an optional condition. All right, what does this mean? Let's take an example, right? Here we have a loop that's iterating through a list variable called nums. So nums, we are assuming here it has a certain list of numbers, okay? Because the operation we're performing is squaring. And then the optional condition here, what it's doing is it's checking whether that number is odd or even. And if it's even, it gets squared. So by the end of this for loop, you will have a list of numbers that are even squared. Okay, very simple. So we'll see several examples like this later. But let's dive in a little bit deeper. The most important question is, why do we need list comprehensions? There are several ways you can create lists and modify them in any way you want, but you can use, for example, for loops to do exactly what we've done right here as an example, but that would take 3 to 4 lines. Or in some cases, you can use functions like map or filter to do what list comprehensions are doing, but that's not readable, right? So we get conciseness, readability, and performance. List comprehensions are much more performant than any of the alternatives, your nested for loops or your maps, your filters. None of them come close to list comprehensions when it comes to performance, and I'll prove it to you that that's the case. All right, moving on. Let's see some examples. What we want to do here is filter out odd values from our numbers. So let's print out numbers and see. So we get the numbers list. So there are several ways you can go about doing this. The first one could be for loop, because we're trying to collect odd numbers. Modulo 2 is not equal to 0. Then we add it to our odds. But we can use filters, for example. So filter, let's create a lambda function, pass our sequence here, which is numbers. So let's go ahead and print that and see what comes up. See here we get filter object. Okay, we don't even get a list value here, so we'll have to modify this. Then only you can see the filtered value, which is not only time consuming, but also you'll have to convert the filter object into lists. There's another layer of computation that's getting performed here. What about our list comprehensions? So our list comprehension goes like this. We have a for loop, right? And we're iterating through our input sequence, which is numbers. We have our output sequence, which is X, getting collected here. And then we have a conditional statement that we're using to filter out evens and odds. So let me go ahead and print this. Excellent. Same, if I want to square numbers, for example, all I have to do is just print. I can even do it in print statement. X for X in numbers and square it. There you have it. If you weren't doing this, what you would need to do is use a map. It's a higher order function, right? You'll have to have a lambda function, X square, and then you pass in numbers. The surprising thing is this doesn't even give you a list. So you will have to go ahead and convert this into list. That's another way to do it. You can use for loop again for squaring. So we get it, right? So you can use filters, for loops, maps, and whatnot. But the most concise and powerful way is using list comprehensions. And now I talked about list comprehension being performant, right? So let's get that performant to the test, right? So we can use time it in order to time the time it takes for a certain computation to be performed. So here we're trying to do exactly what we've done earlier. We're just filtering out all the odd numbers, right? This is exactly what we have here. And I'm timing that and comparing it with what I've done with filters, right? Doing the same thing here, but using filters. So let's run this and see. So yeah, okay, so this operation took 599 nanoseconds using list comprehension. So let's see filters. Okay, this is 996 nanoseconds. It's very clear that list comprehensions are concise and performant. Okay, another comparison that's comparing list comprehensions against filter, because I guess filter comes closer to list comprehensions when it comes to conciseness. The only downside with filters is that A, doesn't give you a list as an output result, and B, it's not concise enough. Like, you'll have to know what filter does before you start to use it. Not that it does something complicated, but you have to define lambda function and all that stuff, whereas this is very clear and understandable. So readability is another downside to filters and maps. So just to compare, let's run that and see. Okay, 435 nanoseconds and 706 nanoseconds. Quite the difference there. Okay. All right, so another handy way of using list comprehensions is to flatten a nested list. A nested list could be something like a matrix, for example. So we've kept a variable called matrix in this example. Let me just go ahead and comment this one. So our matrix variable has this sort of list. So it's list within list, lists within list, right? So let me just comment this back so we can see what our matrix variable looks like. Okay, yeah, this is how it would look like. So now what we want to do is we want to take the inner lists. We want to take the numbers from the inner lists and keep them in one long list. Again, several ways to do this. You can use a for loop, for example, to do this. Let me just do that. For numbers in matrix, and then for num in append nums. Here I'll get exactly what I'm looking for. And this is what I got right now. So it takes 4 lines of for loop, and 2 for loops and 4 lines of code in order to accomplish this. Whereas if you use list comprehensions, it's quite easy to do. Or we just call it flat, right? So I'm looking for num, and again the same thing for numbers in matrix, for num in numbers. So what we're doing here is our numbers variable is an iteration of matrix, and our num is an iteration of numbers. So outer loop, inner loop, and then output expression here, print flat, and that's it. Single line of code, super efficient, easy. There is not a better way, there is a hack, some sort of a hack you can do. For example, here, flat sum, right? You can use sum to do the same thing, like pass matrix and then pass empty list. And if you print flat sum, you get exactly what we got earlier. Very concise, but not efficient and performant, so be careful using this. But the best way is to use iterTools chain function, which I won't be covering here. Now let's work with some sentence, for example, some string. String is also a sequence, so let's see what's that all about, right? So here, let's try and create a list of words, okay? So the easiest way to do it again here is to use, of course, list comprehensions. And how to do that is this way. We say word in for word in sentence dot split. So we're splitting the sentence by space, and there we have it. And now let's say we want to, instead of the words themselves, we want to keep a list of length of these words. So the way to do that is again very easy. Print len word, right, for word in sentence. And now let's say I want to keep only those that are even number words. Why do I do that? I don't know. But how I can do that, I know. Modulo 2 is 0, then we keep it. And I can filter words again by their length. Len. So these words are list, comprehensions, needs. And last but not least, bonus is list comprehensions. And not the only comprehensions, you have dict comprehensions or dictionary comprehensions. What do we do with this? For example, here I am iterating through sentence, picking out words because I'm splitting the sentence by space, and I'm creating a dictionary of words, their length being the value. So each word is a key and its length is a value. And here I have added a conditional statement that filters our dictionary based on the number of characters or the length of the word that I have. So this one prints out all words mapped to their length. But again, here I can add filter. I can, keep all words that are 3 character length. And that's it. I hope you learned something new. Thanks.